Let's talk about A2L refrigerant leak mitigation. Recently I attended an A2L class and I asked the instructor what type of sensors were used to detect the leaks. Unfortunately, he couldn't provide a clear answer. He mentioned something about resistance and then changed the subject quickly. Well, I wasn't satisfied, so I went home and I did some research. What I saw was there's two types of sensors. The first one we'll get back to. The second one here is an NDIR or non-dispersive infrared sensor. This sensor allows air to enter, it shines an infrared LED and measures the brightness using this infrared receiver. When the A2L gas is present, it changes the amount of light hitting the receiver, and that's how it detects the leak. Now this second sensor is even cooler. This is an RGD sensor, which stands for Resonance Gas Detection Sensor, a fancy name for a speed of sound sensor. Now the speed of sound at sea level in air is a known value, 760 miles per hour, but the presence of an A2L refrigerant alters the air's properties, slowing down the sound waves. This sensor works by transmitting an ultra-high frequency sound wave. It bounces off nearby objects and returns to the sensor. It establishes a baseline and detects any changes in the timing of the sound wave. This principle also is why the sensor has a 15-year lifespan. It's not an active sensing element. It's basically a speaker and a receiver diaphragm. Both the NDIR and RGD sensors have built-in microcontrollers, and they communicate with the main mitigation board via Modbus communication protocol. So the four wires from the sensor consist of power, ground, and the communication bus, positive and negative. Because these are communicating sensors, you really can't measure the sensor itself. Well, this gave me an idea. I have an Arduino programmable microcontroller and an ultrasonic distance detector that operates similar to the RGD. Using those, along with two LEDs and a relay module, I created a mock-up mitigation system. I built a small rooftop evaporator section with a coil, refrigerant sensor, blower housing, and I used a PC fan. I wrote some code so that when the ultrasonic detector detects my fake refrigerant, it turns on the red LED, energizes the relay, and starts the fan to mitigate the leak. I have to say it works pretty well. Within seconds, it mitigates and disperses the fake refrigerant. When the situation's clear, the fan shuts off. Now this video focused just on the sensor. However, the mitigation board also performs other functions, such as disabling any spark-creating devices like a furnace or the compressor contactors. During active detection, once the detection clears, it automatically resets to normal. I'm Professor Butler, a 20-year HVAC service technician. If you got something out of this video, how about a follow? If you have any other questions, leave me a comment down below. Thanks for watching.